Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem number 12, fluid mechanics. Okay. As usual, we first come towards statement. Okay. If 5.0 liter of antifreeze solution whose specific gravity is given as 0.80. Dear students, we know that specific gravity has no units, it is just a number. Okay. If 5.0 liter of antifreeze solution have with specific gravity 0.80 is added to 4.0 liter of water to make a 9.0 liter mixture, then what is the specific gravity of the mixture? Okay, dear students, quite simple. The main thing used in this problem is the definition of density and specific gravity. Okay, we know that specific gravity of any fluid is the ratio of density of that fluid to the density of water. And we know from table of densities that density of water is 1000 kilogram per meter cube. Okay. So on the basis of these two definitions, we will solve this problem quite easily. Okay. Now we come toward its solution. Starting mode will be similar as in our previous modules of fluid mechanics. Okay. Solution. Density is mass per unit volume. If a mass m of a homogeneous material has volume V, then its density rho is given by rho equal to mass over volume, rho equal to m over V. Here, in place of sign of equality, we can also place three parallel lines, meaning horizontally parallel lines, which will be read as rho is defined as mass per volume. Okay. We give equation number 1 to this expression. Okay. We know from table of densities that density of water is 1000 kilogram per meter cube. Okay. Dear students, we should not give reference of table of densities. Okay, because density of water is used very often in fluid mechanics, so we should remember this value, that is 1000 kilogram per meter cube. Okay, however, as a formality, we show this table. Okay, this is water 1.00 into 10 raised to the power 3 kilogram per meter cube. Okay. We know from the table of densities that density of water is 1000 kilogram per meter cube. Okay, now let we denote density of water by rho W, where W is written as a subscript of rho, and density of antifreeze as rho antifreeze, where antifreeze is written as a subscript of rho. Okay, let rho W equal to density of water equal to 1000 kilogram per meter cube as given in the table of densities, and we denote density of antifreeze by rho antifreeze, where antifreeze is written as a subscript of rho. Okay, here we have just denote density of antifreeze. Okay, we have not found its value yet. Okay, let V antifreeze is equal to volume of antifreeze, which is given in the statement, that is 5.0 liter. Similarly, volume of water, which we have denoted by V water, where water is written as a subscript of V. Similarly, antifreeze is written as a subscript of V. Okay, V water equal to volume water, or volume of water equal to 4.0 liter. Okay, these two values have been provided in the statement. Next, volume of mixture, V mixture, where mixture is written as a subscript of V, equal to volume of mixture equal to 9.0 liter. Okay, what we have done, we have simply added these two volumes, that is volume of water and volume of antifreeze. Okay, 5 plus 4 equal to 9 liter. Okay, let us denote mass of antifreeze by M antifreeze, where antifreeze is written as a subscript of M, and we have yet to determine its value. That is why it has been written equal to sign of interrogation. Okay, similarly, we have denoted mass of water by M water, where water is written as a subscript of M, and it has been written equal to sign of interrogation, because these two quantities have yet to be determined. We have yet only denoted these two quantities in some specific form. Okay, as per equation number 1, density is equal to mass over volume. Okay, so 1000 kilogram per meter cube, this is the density of water, equal to mass of water over volume of water. Volume of water is 4 liter. Okay, volume water 4 liter. Okay, here we have just applied equation number 1 to density of water. Okay, so density of water, which is given in the table of density, that is 1000 kilogram per meter cube, is equal to MW, that is mass of water over volume of water 4.0 liter. Okay, 4.0 liter is given in the statement. Left hand side value is given in the table of densities. Okay, and mass of water is yet to be determined. That, okay, that is why we have used this sign of interrogation. Okay, so from here, by simplifying it, we do not go into the detail of simplification. Okay, because it is a matter of low classes. We can safely ignore simplification process. Okay, this implies that mass of water becomes equal to 4.0 kg kilogram. Okay, mass of water has become equal to 4 kg. Now we move towards the next. Now, specific gravity of antifreeze is equal to density of antifreeze over density of water, because by definition specific gravity is the fraction, is the ratio of density of that fluid to density of water. Okay, so specific gravity of antifreeze is equal to density of antifreeze over density of water. Okay, dear students, here in this statement specific gravity of antifreeze is given, and from table of densities density of water is given. Okay, one thing is given in the statement, one thing is given in the table. So quite clearly, quite easily we can safely find out the remaining third value. Okay, so here we have put the value of specific gravity of antifreeze, which is given in the statement as 0.80. Similarly, density of water given in the table is given 1000 kg per meter cube. So from here, the third unknown quantity can be very easily calculated, which becomes equal to density of antifreeze is becomes equal to 800 kilogram per meter cube. Okay, dear students, we know that density of water is 1000 kilogram per meter cube, while density of antifreeze has become equal to 800 kilometer per meter cube. Okay, meaning nearly equal, 800 and 1000, not very much a difference. Okay, because here density of antifreeze will become equal to 0.80 multiplied with 1000 kg multiplied with m raised to the power minus 3. Okay, because dear students, this is in the denominator, it will automatically become in the numerator on this side. When it will be shifted on the other side, then it will become in the denominator. Okay, here this m cube is in the denominator on the lower side, so it will actually be treated as in the numerator as m3 positive, but when it will be shifted on left side hand side, it will become 10 m raised to the power minus 3. Okay, so m raised to the power minus 3 will be written as kg per meter cube. Okay, so we have found the value of density of antifreeze, which has become equal to 800 kilogram per meter cube in comparison with density of water, which is 1000 kilogram per meter cube. Okay, now again using the question number 1, density of antifreeze is equal to mass of antifreeze over volume of antifreeze. Okay, this implies that in place of density of antifreeze we have used its value, which we have calculated in the above part. Okay, dear students, we have again come on our page. There was a minor irregularity in computer software. Okay, we to this extent we had discussed our problem. Okay, density of antifreeze had become equal to 500 kg per meter cube in comparison with density of water, which is 1000 kilogram per meter cube. Okay, this density is given in the table of densities, but it is so frequently used in fluid mechanics that we must remember it. Okay, now again using equation number 1, density of antifreeze is equal to, we know by definition that density is equal to mass over volume. Okay, so when density of antifreeze is under consideration, then mass of antifreeze will be divided with the volume of antifreeze. Okay, we have found this value in the above part of this module, 800 kilogram per meter cube. Okay, mass of antifreeze is yet to be determined. Okay, we have not changed this portion. However, volume of antifreeze is given in the statement, which is 5.0 liter. Okay, so from these three values we can safely find this value. Okay, because when we will keep mass of antifreeze on one side, then 5.0 liter will be multiplied with 800 kilogram per meter cube. Okay, this implies that mass of antifreeze is equal to 800 kilogram per meter cube into 5.0 liter. This alternatively becomes equal to 800 kilogram per meter cube into 5.0 into 10 raised to the power minus 3 meter cube. This point needs a little explanation. Okay, dear students, we know that 1000 liter is equal to 1 cubic meter as per table of conversion factor, which we will now show below this step. Okay, so when 1000 liter is equal to 1 cubic meter, then 1 liter will be equal to 1000 part of a 1 cubic meter. Okay, let us move toward that table of conversion factors. Okay, this is the table. Okay, here dear students, we can see that 1 liter is equal to 10 raised to the power minus 3 cubic meter. On the other hand, 1000 liter is equal to 1 cubic meter. Okay, this point has been applied at that point. Okay, 1000 liter is equal to 1 cubic meter. Similarly, 1 liter is equal to, here again 1 liter is equal to 1 into 10 raised to the power minus 3 cubic meter. Okay, this point has been applied at that point. Okay, so this here we have used, in place of liter we have used 10 raised to the power minus 3 cubic meter. Okay, I have already stated that 1000 liter is equal to 1 cubic meter. 1000 liter is equal to 1 cubic meter. So 1 liter is equal to 1000 part of a cubic meter. That is why 10 raised to the power minus 3 cubic meter. Okay, Here cubic meter will be cancelled out with cubic meter. Moreover, 10 raised to the power minus 3 will be treated as divided by 1000. When divided by 1000, 2 0 will be cancelled out with 2 0 in the denominator, and 8 into 5 equal to 40. Okay, 40 divided by 10 will become 4 kg. Okay, so this simplification process was actually not necessary to explain, but because a conversion factor was involved. Which conversion factor? The conversion factor that 1000 liter is equal to 1 cubic meter. So 1 liter is equal to 10 raised to the power minus 3 cubic meter. Okay, now specific gravity of mixture is equal to density of mixture over density of water. Okay, because it is a very basic thing that by definition specific gravity of any fluid is equal to density of that fluid divided by density of water. So here density of mixture is equal to mass of mixture over volume of mixture over density of water. Here again we can write it in the form as mass of water over volume of water, but we have directly put the value of density of water from the table of densities, 1000 kilogram per meter cube. Okay, dear students, we have already calculated these two values. Okay, this value we have calculated in the previous step, while volume of mixture is given in this statement. Okay, both volumes are given. Volume of water is also given and volume of antifreeze is also given. So by adding 5 liter plus 4 liter, we have become able to calculate the volume of mixture. Okay, 5 liter plus 4 liter is equal to 9 liter, and mass of mixture we have calculated in the above part. Okay, density of water has been taken from table of densities. So here what we have done, we have simply put all these three values. Okay, so 8 kg over 9.0 liter into this meter cube will become in the numerator, because it is in the denominator of denominator. Okay, so it will become m cube over 1000 kg. Okay, kg will be cancelled out with kg, and it will become 8 meter cube over 9000 into 10 raised to the power minus 3 meter cube. Meter cube will again be cancelled out with meter cube, and 10 raised to the power minus 3 will be treated as 1000 on the upper side. So these three zeros will be cancelled out with these three zeros, and our answer will be 8 over 9. Okay, when we divide 8 by 9, 8 over 9, it takes the form as 0.888888888888. Okay, so we can simplify it or round it as 0.89, because here the second digit after 8 is greater than 5, so it will be converted into 0.9. Okay, we can also write it as 0.9. We can if we take these three values, then after 88, third figure is again greater than 5, so this 8 will be converted into 9, so it has been rounded as 0.89, and this is the required solution of our problem, that is specific gravity of the mixture. And this is the end of our module. We have previously discussed these two tables and there is no need to further explain. Now we come towards the reference. Reference from where we have chosen this problem. Reference book is Physics for Scientists and Engineers with Modern Physics. Author is Douglas C. Giancolli. Publisher is Pearson and its fourth edition 2009 has been adopted and followed. Here chapter number 13 under title Fluids is our concerned chapter, and this problem has been enumerated at serial number 6 of the exercise of this chapter, that is exercise number 13.6, and this is the end of our module. Okay.